Okay, so here's the video for Cycle A Phase 2. And we're still working with limits, um, specifically today, left-hand limits or limits from the left. So remember, a limit is the final utmost or furthest boundary. And yesterday's notes um, also described a limit as this: a number that we can always get closer to but never pass. So the directions are given the following functions. I said piecewise initially, but I changed it because only the third one is piecewise. Given the following functions, use a table of values to determine the left-hand limit or the limit from the left. So over here, we're going to have a table of values. We're going to have inputs and outputs. So what this, you're going to see a lot of like new notation this year. And so this is an example of the type of notation you're going to see. So the way that this is read is the limit as x approaches 6 from the left of x minus 8 to the fourth. Okay, the arrow, it means approaches. So x approaches 6, and then that little negative means from the left. If this little negative was positive, it would mean from the right. So the limit as x approaches 6 from the left of x minus 8 to the fourth. Okay. Yeah, so using a table of values, and I'll explain to you, how to do this as we go. So what I want to do here is I want to put some values in this table that are to the left of 6 and getting closer. So let me just think for a second. So here's 6. So x is approaching 6 from the left, right? From the left-hand side. So, oh, and here's like 5. 5 is like over there. You don't want to start at 5. You want to start like pretty close to 6 to begin with. For example, 5.9. All right, it's like 5.9 is pretty close. So we'll start with 5.9. So we're at 5.9, very close to 6. And then we want to plug in, so that'll be our first input value. Then we want another input value that's even closer. So you just put in another 9. So 5.99. And then you want to get even closer. So 5.999. So the question is, guys, that we want to ask ourselves is, as x approaches 6 from the left, okay, so this arrow diagram, we're going to be using these arrow diagrams. Y approaches what? Okay, so that's the question right there. Y approaches what? So what you're going to do is we're going to use our calculator, the table in our calculator, to plug in these values and get some corresponding outputs. We're going to look for a pattern in the outputs and see if, in fact, y is approaching some number as x approaches 6 from the left. So I'll show you like how to do it. So I go here, y equals, all right, and I'm going to type in the function x minus 8 to the fourth. And I'm getting a new camera, guys. I'm sorry about the quality of the video at this point. I'm just using a webcam, and but I'm getting a nice camera, so the quality will improve. All right, so I type that into y1. Now I want to go to the table, so that second graph is the table. Right now, the calculator itself is generating the inputs, but I want to be able to choose the inputs. So I'm going to go to table set, which is above window, so second window, and I want the independent variable, which is the input. Instead of being on auto, I want to put it on ask. So that's what's going to let me plug the stuff in. All right, so I'm plugging in 5.9. 5.999, 5.999. Okay, so I'm going to write those values down. So this is 19.448, 16.322, 16.032. All right, now when we're asking ourselves what y is approaching, we want to keep, this definition or this idea in mind. We're looking for a number that we can always get closer to but never pass. So as the input values are approaching 6 from the left, are the output values, is there a number that the output values are getting closer and closer to but not passing? So, and if you can't tell, guys, from just 3 values, then keep going. Keep adding more nines. So I'll go 5.9999. Ooh, and look at that, 16.003. So if we look at this pattern, it looks like the number that the y's are getting closer and closer to, but not passing, is 16. So this is the limit. That's the answer. That's the number that the y values are getting closer and closer to and not passing. So the answer here is 16. So the limit as x approaches 6 from the left of x minus 8 to the fourth equals 16. Okay, let's do this one. So now this is the limit as x approaches negative 7 from the left of this function here. So let's figure out what type of values. So here's negative 7. We want to use values very close to negative 7, but to the left of it. So negative 7, this would be negative 8 here. So what's a number to the left of negative 7, but very close to it? In this case, guys, so with this case, we had a positive 6 that we were approaching from the left. So we started at 5.9. That was really close. 5.99, 5.999. But a number to the left of negative 7 that's really close, let's do negative 7.1. Negative 7.1. And now I want to get closer. I still want to be to the left of negative 7, but I want to be closer, so I'll do negative 7.01. And then I want to be even closer, but to the left, negative 7.001. And I'm asking myself, as x approaches negative 7 from the left, what are the y values approaching? Is there a number that we are getting closer and closer to, but never passing? So I'm going to do the same thing. So what is it? Alpha y equals. All right, so this is x squared over x plus 7. And I'm already on table set. So I go to my table. Oh, and I still have those same. Shoot, I don't want those. Is there a way to clear them? Oh, I could just type over them, I think. Yeah, I could just type over them. So here I want negative 7.1. Enter. Oh, shoot. All right, you know what? I want to see decimals. Okay, because I used alpha y equals to get that fraction, it's going to be giving me fractional answers. And I want decimals. So instead I'm going to go x squared divided by x plus 7. And that should give me decimals. Yes, it did. Okay. All right, so we got negative 7.1. There's the output for it. Negative 7.01. Negative 7.001. And then negative 7.0001. Okay. So my numbers are, my outputs, negative 504.1, negative 4914. negative 49014. And then it's really kind of hard for you to see unless you're doing this along with me, but this little backwards e just means 10 to the, so this is negative 4.9 times 10 to the fifth, which is negative 4.9 times 10 to the fifth. It's this really big negative number. So what you see here, guys, is that for every little small change in x, we're getting a huge change in y. These numbers, I know that they're getting more negative. They're getting bigger in a negative direction. So they're getting bigger in a negative direction, and they're jumping they're jumping really a lot for every little small change in x. So we're asking ourselves, is there a number that we are getting closer and closer to but never passing? Guys, that no, we're passing every, we just keep passing in huge ways all of the numbers, and we're going further and further to the left. So if you're going further and further, these y's are getting like more and more negative. So what's happening is that what y is approaching in this case is negative infinity. All right, and what negative infinity means is that we just keep going and going and going in a negative direction. So in this case, the limit is negative infinity. Alrighty. Now here's the piecewise function, and on your practice problems, they're all like piecewise functions. So here they have defined g of x for us, and we're doing the limit as x approaches negative 1 from the left, and then we're also going to do the limit as x approaches 5 from the left. So I wrote in like another table here. So, okay, so for this first one here, right, there's negative 1. I want to approach it from the left, so I'm thinking of numbers like negative 1.1, negative 1.01, negative 1.001, right? So if I'm plugging in numbers like this, like negative 1.1, all of these, which of these two pieces am I going to be using? Well, all of these numbers, guys, are less than negative 1. They're less than negative 1, so I'd be using this, that there. So that's what I'm going to plug into y equals. So I'm plugging in 2x plus 3. 2x plus 3. All right, and I'm going to plug those in. Negative 1.1. Negative 1.01. Negative 1.001. All right, 0.8. 0.98. 0.998. Guys, as x is approaching negative 1 from the left, what are these y's approaching? What are they getting closer and closer to? They're getting closer and closer to, and you could always do like another one, negative 1.0001. They're getting closer and closer to 1. So that would be the limit for that top one. Now, for this example, we want to approach 5 from the left. Right, so approaching 5 from the left, that's like 4.9. 4.99. 4.999. Oh, so what am I plugging into? So these numbers are not less than negative 1. So I wouldn't be using this piece here. These numbers are greater than negative 1. So I'd be using the greater than or equal to negative 1 part, which is x squared. So I gotta go y equals, so that's x squared. 4.9, 4.99, 4.999, 4.9999. Okay, so I've got 24.01, 24.9, 24.999. And here, as x is approaching 5 from the left, the y's are approaching 25. So that's what the limit is for this one. Okay, guys, so I'll talk to you later. Bye-bye.